Hi, 7th graders. We are on lesson 3.1, which is square roots. Our learning target is I can find square roots of perfect squares. So if we look at these numbers, 1, 4, 9, 16, 25, think in your head if you can think of a pattern that we see going on or what these numbers have in common. Okay, if we think of 1 and we make a square to make an area of 1, so in here, because it's really small, I'm going to write it out here. Area equals 1, well that means that our sides would have to be 1 by 1, because 1 times 1 equals 1. If we want to have an area of 4 for our square, that means our side would have to be 2 and 2, because we have squares here, our sides are equal. 2 times 2 equals 4. Okay, so if you can see a pattern forming here, we would have 3 by 3 to get an area of 9. So then we would have 3 times 3 equals 9. And then we'd have 4 times 4 equals 16. And what would we have on our last square? We would have 5 times 5 equals 25. So these numbers right here (1, 4, 9, 16, 25, ... meaning that it goes on and on) are called perfect squares. Okay, perfect squares are, that means that they are squares of integers. So we can write 1 times 1. Well, 1 times 1 is the same as 1 squared. So 1 squared equals 1. 2 times 2 is the same as 2 squared. So 2 squared equals 4. So all of these numbers, 1, 4, 9, 16, 25, the next one would be 36. All of these have a integer, a number that can be multiplied by itself to get that number. 3 times 3, 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. Okay? So perfect squares, 1, 4, 9, 16, 25, 36. 6 squared equals 36. Our next one would be 49, because 7 squared is 49. What would our next one be? 64, because 8 squared is 64. Our next one would be 81, because 9 squared is 81. And then we have 100, because 10 squared is 100. Okay, so the square root is the opposite of finding the square of a number. Okay, so if we have 4, we want to find the square root of 4. Well, we would use this radical sign. This is called a radical sign. Okay, it's used to indicate the positive square of a number. So the square root of 4 then equals 2, because 2 times 2 equals 4. The square root of 25 equals 5, because 5 squared equals 25. Notice that the square root is just the number, not the number squared. Okay? So if we have the square root of 49, well, we were just listing them up here. Well, we can think in our head, what number times itself, or what number squared equals 49? And we know that 7 squared equals 49, so the square root of 49 equals 7. Okay? Here we have the negative square root of 25 over 36. So if there's a fraction under the square root, we take the square root of the numerator and the square root of the denominator. So I'm going to ignore this negative sign for a second. The square root of 25 is 5, and the square root of 36 is 6. Remember, because 5 times 5 equals 25, 6 times 6 equals 36. Okay, so the square root of 25/36 is 5 6. But then it wants us to take the negative of the answer. So our negative is just going to go with our answer. So we have negative 5 6. Okay, if we have the square root of 1.21, well, we know that the square root of 121, if you can think about what that is, the square root of 121 is 11, because 11 times 11 is 121. Okay? But because I have a decimal right here after my 1, my answer is actually going to be 1.1. Okay? So now it's telling us it wants the positive and the negative. This is what this sign means right here. The positive and negative square root of 1.21. Okay, so 1.1 squared is 1.21. Negative 1.1 is also an answer because if we think about it, negative 1.1 times negative 1.1, you get 1.21, because if we have a negative times a negative, we get a positive. So actually, the square root of 1.21, the answer is 1.1 and negative 1.1. Because it has this sign in front of it, it tells us that it wants the positive and the negative. Okay? Looking back up here at square root of 49, it's just telling us that it wants the positive answer. This is telling us that it wants the negative answer. Okay? So say we have some variables involved here. So we have a squared equals 169. Well, in our head we think, well, a, what number squared equals 169? Okay? Well, the opposite of squaring a number is taking the square root. And if you think back to solving one-step equations, we take the opposite of what's being done to the variable to get rid of, or to get the variable alone. So I'm going to take the square root of a squared, and then I have to take the square root on the other side. Because whatever I do to one side, I have to do to the other side. Okay? And to show you super quick why this works, if I have 5 squared and I take the square root of it, well, I know that 5 squared is 25, so that would be taking the square root of 25. And we know that the square root of 25 equals 5, because 5 times 5 equals 25. So in the end, I'm left with just my number, 5. So the square root cancels out my square, and I'm just left with the number. So therefore, the square root cancels out my square, and I'm just left with a, which is a horrible a. A equals the square root of 169. Well, I know that 13 squared equals 169. So my answer, a equals 13, but it also equals negative 13, because this time it's just telling us what could go in for a. Well, I know that 13 squared equals 169, but I also know that negative 13 squared, because remember negative 13 times negative 13 is positive 169. So we have two answers, and it's very important that you include both of the answers. Okay, 4 25ths equals y squared. So I'm going to, because the y is being squared, I'm going to take the square root on both sides, because again, that's going to cancel everything out. So I'm left with y, and then I take the square root of 4, which is 2, and the square root of 25, which is 5, and that's my answer, 2/5. It's getting rid of the square root there, okay? And it also equals negative 2/5. Because I know negative 2 times negative 2 is 4. 5 times 5 is 25. So we have 2/5 and negative 2/5. Okay, a concert crew needs to set up 900 chairs on the floor level. If the chairs are placed in a square arrangement, how many should be in each row? So basically we want to know how many rows and how many columns. Since it's a square, it's going to be the same number. So I would write this as x. I know that x times x equals 900, which is the same as x squared. So x squared equals 900. So then to solve it, we take our square root on both sides. So that cancels that out. X is alone. Square root of 900. I know the square root of 9 is 3. 3 times 3 is 9, but 30 times 30 is 900. So that means that there are 30 chairs or 30 rows and 30 columns. So 30, how many should be in each row? So it would be 30 chairs, because we always want to include our label. Okay? So just to recap, let's do this is the difference between squares and square roots. 9 squared equals 81. 9 times 9 equals 81. The square root of 9 equals 3, because 3 times 3 equals 9. If you are still confused, go back and read page 144 and 145 in your textbook. Okay, and really quickly, I want you to find the square root of A, B, and C. So the square root of 9 is 3, and the square root of 16 is 4. So the answer would just be 3/4, because it's not telling us to give the positive and the negative, just the positive. But if you did 3/4 and negative 3/4, that is fine. Okay, the negative square root of 49, square root of 49 is 7, and then I bring my negative out, so it's negative 7. The positive and the negative square root of 0.81, well, I know that the square root of 81 is 9, so the square root of 0.89 will be 0.9, so it's positive 0.9 and negative 0.9. Okay? And really quick to check to make sure that we understand squares and square roots. What is 4 squared? Write it in your notebook. And what is the square root of 4? Write it in your notebook. Okay? And I want you to pick one more number to write the square of and a different number to write the square root of. And then go on to Naiku and do the 3-1 quiz. And I'll see you tomorrow.